Hey guys, this is video 6 of chapter 3. We're going to be talking about determinants and inverses of matrices. Okay, so here we go. A determinant of a matrix. Okay, so let's say we have a matrix A, B, C, D. We're only going to talk about determinants of a 2 by 2. I will show you how to do a 3 by 3 actually in class. So determinant of a 2 by 2 matrix, 2 rows, 2 columns, is we're going to take A times D, so these two values, and we're going to subtract C times B. So if we look at number 1 here, we're going to take 6 times 2. So we're going to go this way first, and we're going to subtract 3 times negative 5. So 12 minus negative 15, so 27. Okay, so number 2, we're going to take negative 4 times 3. We're going to subtract negative 2 times 9. So negative 12 minus negative 18, which gives me 6. All right, next we're going to talk about inverses. Okay, so to do an inverse of a matrix, you actually have to first find the determinant. Okay, so again, we're going to look at a matrix, just a 2 by 2. So this whole video is about 2 by 2 matrices. We'll talk about some 3 by 3s in class. Okay, so to find the inverse of a matrix, we're going to find the determinant first, and we're going to put 1 over that determinant. Okay, so, and then we're going to flip our A and D values. So we're going to flip A and D around, and we're going to make B and C negative, or opposite of what they are. Okay, so if your determinant is 0, that means we're dividing by 0 here, which can't happen. Okay, you can't divide by 0, so there's no inverse then. Okay, so let's find the inverse of this guy. So step 1, find the determinant. Okay, so 3 times 1 minus 2 times 6. So 3 minus 12 gives me negative 9. So my determinant equals negative 9. So to do the inverse then, I'm going to say 1 over negative 9, 1 over the determinant, and I'm going to draw my matrix symbols here. I'm going to flip my A and D, so 1 and 3 flip. And 2 and 6, I'm going to make opposite of what they are. So they become a negative 6 and a negative 2. And now I'm going to multiply the 1/9 by everything. So this is multiplying by a scalar, which we did 2 videos ago. Okay, so 1/9 times 1 gives me negative 1/9. 1/9 times negative 6 gives me negative 6/9, negative 6 over negative 9. 1 over negative 9 times negative 2 gives me negative 2 over negative 9. And negative 1 over 9 gives me, times 3 gives me 3 over negative 9. And then I'm going to simplify this down a little bit, just simplify my fractions. So the first one stays the same. This one becomes just positive 2 over 9. This one becomes a negative 1/3. And this one becomes positive 2/3. So then here would be my inverse. Okay, let's find the inverse of this guy. So step 1, find the determinant. Okay, so I'm going to take 2 times 6 minus 2 times 6. So I've got 12 minus 12, which is 0. So there is no inverse for this, because the determinant is 0, meaning I would divide by 0 up here. All right. Do one more finding the inverse here. Okay, so 7 times negative 1 gives me negative 7, minus 2 times negative 5, so negative 10. So that gives me a positive 3 for my determinant. Okay, so if I'm doing the inverse then, I'm going to take 1 over the determinant. I'm going to flip my A and D, so negative 1 and 7 flip. And I'm going to make these opposite of what they are. So it becomes a positive 5 and a negative 2. And now I'm going to multiply everything by 1/3. So 1/3 times negative 1, 1/3 times 5, 1/3 times negative 2, and 1/3 times 7. And none of these can be simplified, so this is your inverse. All right, for two matrices to be inverses of each other, okay, so this is the last thing we'll talk about. You need to be able to multiply them both ways. So we needed to be able to take A times B and B times A, and they both need to equal the identity matrix. Okay, so let's say I have a 2 by 2 and a 2 by 2. Okay, so let's say this is A and then I have another one that's B. I would multiply them together and they would equal this when I multiply them. That's your identity. And then if I multiply them the other way around, so if I take that other matrix B and I multiply it by this, okay, they would also have to equal the identity. Okay, so if two matrices are inverses of each other, they will always multiply to be their identity. So if you're multiplying two 2 by 2s, you'll get this. If you're multiplying two 3 by 3s, you'll get this. 4 by 4s, you'll get this. So these are the identity matrices for a 2 by 2, a 3 by 3, and a 4 by 4. Okay, so just like in addition and multiplication, there's things we can add to stuff and we can multiply by things to equal the same thing back. So let's say if I have like 2 plus 0, that equals 2. That means that 0 is my identity for addition. Okay, or if I multiply by 1, I get the same thing back. Okay, 1 is the identity number in multiplication. When we talk about matrices, these are that identity number. So if you multiply by this, you'll get the exact same thing back. Okay, so to figure out if two matrices are inverses of each other, so we have two matrices A and B, like I was talking about before. We're going to figure out if they're inverses. So to do that, I need to take A times B, and I'm going to take B times A. Okay? Multiplication in matrices is not commutative, meaning you can't always flip it around, okay? When I do this, they both need to equal the identity matrix. If they both equal the identity, then they're inverses. Okay, so let's actually set this up. So I have 3, -5, -2, 6 times 3/4, 5/8, 1/4, and 3/8. Okay, so this is a 2 by 2, this is a 2 by 2. My result is going to be a 2 by 2. Okay, so for here I'm going to do row 1, column 1. This will be row 1, column 2, row 2, column 1, and row 2, column 2. So row 1, column 1, so that's this guy and this guy here. So 3 times 3/4 plus 3 times 1/4. Then I'm going to go row 1, column 2. So row 1, column 2. So 3 times 5/8 plus 3 -5 times, this should be -5 here. -5 times 3/8. So I went across and down this one. Okay, now I'm going to do row 2 and column 1. So -2 times 3/4 plus 6 times 1/4. And then finally I'm going to do this and this. So row 2, column 2. So -2 times 5/8 plus 6 times 3/8. All right, so this gives me 9 over 4 plus -5/4. Here I'm going to get 15/8 plus -15/8. Here I'm going to get -6/4 plus 6/4. And here I'm going to get -10/8 plus 18/8. So if I simplify that down, I have 4/4, which is 1. I have 0 over 8, which is 0. I have 0 over 4, which is 0. And I have -8, or I have +8 over 8, which simplifies down to 1. So A times B is the identity. Now I just have to do B times A. So I'm going to rewrite it the other way around. So 3/4, 5 ace, 1/4, and 3 ace. And then I'm going to multiply it by 3, -5, -2, 6. Okay, so I'm going to get the same type of result, so I'm going to have this same thing going on because it's a 2 by 2 and a 2 by 2. So now I'm going to go row 1 and column 2. So I have 3/4 times 3 plus 5 ace times -2. Then I've got 3/4 times -5 plus 5 ace times 6. Then I'm going to go down here and here, so 1/4 times 3 plus 3 ace times -2. Then I'm going to do finally row 2, column 2, so row 2, column 2. So 1/4, -5, and 3 ace and 6. And then I'm going to simplify that down. So 3/4 times 3 gives me 9/4. 5 ace times -2 gives me -10 ace. 3/4 times -5 gives me -15/4. 5 ace times 6 gives me 30 ace. 1/4 times 3 gives me 3/4 plus -6 ace. And then finally I've got -5/4 plus 18 ace. And if you were to add all those fractions together in your calculator, you're going to end up with the identity as well. So if you were to actually add these in your calculator or simplify them down, you would get 1001. So therefore, AB and BA both equal the identity, so yes, they are inverses. All right, and that is inverses and determinants of matrices. We will see you next time.